Okay, let's just jump right in and deconstruct this absolutely mesmerizing feat of mechanical choreography. What we're looking at today isn't just some desk toy. It's really a masterclass in precision manufacturing, and honestly, a perfect example of this booming market for high-end tactile collectibles. In a world completely obsessed with digital CGI and disposable plastics, we're going to break down a sequence that feels like pure magic but is actually a triumph of physical, believable engineering. This right here, this is exactly where mechanical art meets some really serious commercial value.
Now, right from the opening frame, we're hit with the ultimate artistic constraint, a single, uninterrupted, long take. First-person perspective, no cuts, no sneaky digital transitions to save a few bucks on production. The whole shebang happens in real time. And let me tell you, from a manufacturing and design standpoint, this is a massive risk. I mean, there is literally nowhere for the mechanics to hide if a gear slips or a hinge catches, right? It has to perform flawlessly right out of the gate to prove its worth to buyers.
So that brings us to the core mystery of our explainer today. How exactly does a compact, geometric chunk of brass become a sprawling, organic stag beetle without a single camera trick? It's literally a million-dollar design question. Unpacking how this brilliant engineering bridges the gap between rigid metal and organic life and, creates a wildly lucrative collectible in the process is exactly what we're going to figure out together. To put this into perspective, let's look at the sheer speed of this sequence. It is mind-blowing. At the 1 second mark, we get activation. By 3 seconds, the armor rotates. By 8, the legs extend, and boom, we hit a lifelike stance at 15 seconds flat. Packing this much mechanical action into just 15 seconds? That requires a level of R&D and rapid deployment design that honestly rivals high-end industrial robotics. It's just efficiency and speed working in absolute perfect harmony.
It all starts with an incredibly tactile user experience. The action kicks off with human touch, a thumb pressing that super satisfying red mechanical button. You hear that crisp metallic click? That's a sound acoustic engineers spend months, sometimes years, perfecting. It signals the release of stored energy and basically screams premium build quality to the consumer. The object gets placed gently on a wooden table, the camera locks in, and the stage is set.
And then comes what is absolutely crucial here, the strictest rule of physical volume: 0 new components. As those tiny locking pins retract, every single thing that happens next has to use only the material already sitting right there on the table. Maintaining that realistic volume without cheating, without parts just magically appearing out of thin air, is exactly what separates cheap novelties from these highly sought-after masterworks of kinetic art.
Literally every single moving part originates from the existing object. All those gears, the rotating drive shafts, the folded limbs, they're all intricately packed within that tiny hexagonal core. It's like a giant 3D mechanical puzzle. It's a brilliant exercise in extreme spatial efficiency. Nothing drops in from off-screen, no CGI swaps. It is pure, unadulterated mechanics. And that authenticity, that's exactly what makes it so incredibly valuable to collectors.
Now you might be wondering, how does a small core gain such a massive footprint? Well, we have to look at the telescoping mechanisms. As the outer panels hinge open, they reveal these nested sections sliding outward from the center. This is the mechanical secret sauce. It allows the structure to drastically expand its length without violating our 0 new parts rule. It's an incredibly elegant solution that maximizes scale, but still keeps that compact, easy-to-ship initial form factor.
Okay, the pacing really picks up here. Hidden joints slide outward, letting that telescoping core extend. Then, like a highly coordinated dance, the folded legs deploy section by section. They rotate at multiple articulated joints until 6 slender insect legs firmly hit the tabletop. The simultaneous coordination required here is just staggering. It demands micromillimeter manufacturing precision, because if it didn't have that, the entire mechanism would just jam up instantly, no question.
Right, so now the front assembly splits symmetrically, completely exposing the intricate heart of the machine. You've got these turning brass gears meshing together right alongside tiny, relentlessly spinning flywheels. And this isn't just functional, it's deeply aesthetic. It's the mechanics proudly putting itself on display. It really proves the massive value of its internal architecture to the buyer, rather than just hiding everything behind a cheap plastic shell.
This is the moment the recognizable silhouette really sweeps organically into place. Segmented antennae slide out from concealed channels, locking into position with these tiny little clicks. The entire head assembly pivots upward as layered armor plates shift to form a realistic exoskeleton, and then the crowning feature. Those oversized mandibles telescope outward and slowly open. It's a spectacular, gear-driven reveal that, let's be real, essentially prints money in the boutique practical effects and luxury collectible markets.
The whole experience is just this perfect mechanical symphony of two distinct motions. On one hand, you have the continuous visual flow and that low hum of meshing brass gears. But on the other hand, you have the sharp, punctual clicks of springs compressing and locks engaging. This auditory contrast really anchors the realism. It provides this deeply satisfying sensory feedback loop, which is a massive psychological trigger that premium buyers will absolutely pay top dollar for.
So, the grand metamorphosis finishes up, but the performance actually transitions into something far more intimate, the illusion of life. The dramatic sweeps of shifting armor and extending limbs, those are done. The completed Clockwork Beetle now just stands naturally. The challenge here has abruptly shifted from physically transforming an object to, well, tricking our brains into believing that this cold piece of polished brass is actually a living, breathing creature.
The pacing slows way down here, which lets us really appreciate the micro movements. The antenna gently sweep the air, the legs make these tiny balancing adjustments, and the exposed gears keep turning like a rhythmic heartbeat. And notice how the camera holds perfectly steady. That really emphasizes that these subtle, photorealistic details are what truly bridge the gap between a neat little desk toy and a highly valued piece of kinetic art. It's craftsmanship you can genuinely feel.
We've seen how masterful telescoping joints, uncut cinematography, and clockwork precision can create a totally breathtaking metamorphosis. But think about the broader business implications here. In a world that is so heavily reliant on digital simulation, the consumer demand, and frankly, the lucrative market, for tangible, believable mechanics is stronger than ever. If engineering can make a compact brass toy breathe life without a single camera trick, what other impossible realities are waiting to be physically built? Keep questioning how the extraordinary is constructed. Thanks so much for joining me for this explainer.